So this week's experiment is competing nucleophiles. So first I'm preparing the nucleophile medium. It contains sulfuric acid and equal molar of ammonium chloride and ammonium bromide mixture right here. And in the flask is about 7.5 ml of sulfuric acid, and the medium has to be kept cold, very cold. So I put it at 0 degrees Celsius. So the flask is in an ice water bath. This is to prevent the hydrogen bromide and hydrogen chloride gases from escaping out of the solution. So you don't want this solution to be too hot. So I have to put this mixture 1 scoop at a time, because if I add it too fast, it will react very quickly. So this takes a while, okay? So I've completed adding all the mixture of ammonium chloride and ammonium bromide. So it hasn't dissolved yet. So I'm heating up the solution. And when it's completely dissolved around 45 degrees Celsius, then I will start the reaction. So right now it is all a lot of solid at the bottom. That's fine, let's just wait. So while the nucleophile medium is warming up, we can set up a reflux apparatus. So from here you can see round bottom flask. It has little stir bar at the bottom, so I'm going to use stir bar instead of boiling stones. And we have water condenser, right? So the condenser is empty hole in the inside, it's empty, and the water will comes in from the bottom and out this way. So there's a little O-rings attached to it, inserted in there, and at the top I will connect it to a drying tube, So right, so I'm gonna set up the condenser first. So we need water, so water sauce, reflux, so we need water, and then the top, so it should drain to the sink. Okay, so and I'm just going to clamp it here. Okay, so there's a water tap here. So this one is the water tap, so I'm going to turn it on and you will see the water coming in to the condenser. So let's zoom in a little. So, yeah. So I turn the water on, you see the water rising, and come out from the top. So that's how you cool the vapor, right? The vapor will be rising from the bottom, your reaction flask, and it hit the condenser, and the water is cooling it, so the vapor recondense back into the reaction flask. So the reaction continue in a stable temperature without losing the solvent. So that's how it works. And this is the heating mantle, the aluminum blocks. So it's not quite ready yet, so I have to wait a little longer. So I just set this up for now. So on the top we have a glass wool. I pre-wet it with water. What's the purpose of glass wool? You're going to plug this one into a drying tube here. So drying tube also contains O-rings, right? Don't forget all these little O-rings to prevent the gases from escaping. What's the purpose of glass wool? So I'm just going to attach it to the top. Okay, so this is a good setup. You want to center the aluminum block to the center of the hot plate. That's where the heat is, and make sure that the glass is in contact with the aluminum block. That's where the heat source is. Right, so that's how the setup looks like for now. We're still waiting for nucleophile medium, so I'm just going to measure out the alcohol that I'm going to use today is 1 pentanol, so you need about 0.75 mil, 0.75 mil. So I'm going to use non-jet syringe, so this syringe is calibrated to 1 mil. Okay, so I'm going to take 0.75 mil from here. That's about 0.75 mil, and I'm going to put it into this conical valve and keep it closed. And you don't want this pentanol evaporating. So where should you dispose this syringe and needle? Something to think about. I'm just going to leave it here for now. So the nucleophile medium is ready. So I'm going to pipette out 10 ml into round bottom flask. Most of it is dissolving. That's good. So we'll take 10 ml. Precipitating out because the round bottom flask is really cold, so that's okay. I'm going to heat it up later. So I have 10 ml of nucleophile medium in round bottom flask, and it's stirring and heated. So from the top I'm going to add 1 pentanol using this long glass pasture pipette. That's not good, because this thing is in a way and I can't get my hands straight. Let's turn this around. Yeah, that's much better. So let's try it again. Okay, from the top I put 1 pentanol all the way to the bottom flask here. Slowly adding the 1 pentanol. It's all done. So have it back here and let it reflux for at least 60 minutes. So make sure the round bottom flask is touching the mantle. So you always want to check. Yeah. So it's set as 125. Let's put it at 165 for now, and see where the vapor rings is condensing. Should be around here. You want it at least 1/3 of the way. So now nothing's happening, so that's okay. Right, so it's been refluxing for 20 minutes. You notice the vapor condensing back into the reaction valves, into round bottom flask, so that's good. So I don't think you can see the vapor ring, but it's somewhere around here. But from round bottom flask you can see the vapor condensing back down, so into the reaction flux. So that's good. And so this is reflux setup, and on the top you see the drying tube. You see the gases coming out? Yeah, it's moving around that water damped glass wool, so there's some water in there. So yeah, so that means that's good, reaction taking place. I hope it works. So while we're waiting for the reflux, the 60 minutes, we can do part B. So you can multitask, So I have 6 ml of nucleophile medium in a centrifuge tube, and I'm just keeping it warm in a hot water, and I add 1 ml of 2-methyl-2-butanol. So I use transfer pipette. It's already graded with 1 ml, so that's okay. That's good enough. So 1 ml. And shake for 5 minutes. And make sure to vent it, right? And then shake 5 minutes. So after shaking 5 minutes, you allow the alkyl halides to separate out from the aqueous layer. Okay, so I'm going to let this one sit right here. So you can see the 2 layers are starting to separate. See better here, right? So the top layer is your alkyl halide, and the bottom layer is your aqueous layer, right? That's your excess nucleophile medium. So I'm going to let it sit further. The layer is kind of small, so okay. So it's about 10 minutes already, so here, now we get a better bilayer forming. You can see at the top here is yellowish. That's your alkyl halides. Okay, so I'm going to pipette out the bottom layers. The bottom layer is what? Aqueous? Well, it's written here. So, bottom layer, I'm going to use the transfer pipette to draw it out the bottom layer. Dump it into aqueous waste. It's hard to angle from here, and I don't know if you can see. Yeah, so I drawing out the bottom layer. Yeah, I still have my top layer. Yeah, you have to do this slowly. See that? So I'm slowly removing the bottom layer with Pasteur pipette. Okay, continue. As much as I can. Oops, yeah. That's okay. I took some of the top layer out. That's fine. Well, still have a little bit. That's okay. Huh. Okay. Let's see if I can pipette. That's okay to lose some products anyway, because I really don't want the. Yeah. I really don't want the bottom layer. Yeah. So this is my top layer left at the bottom of the centrifuge tube, and I'm going to transfer this into a smaller test tube which contain 0.05 gram of sodium bicarbonate drying agent. Right? I'm going to use a clean Pasteur pipette. So I have a clean Pasteur pipette, and I'm going to transfer this layer into this little test tube right here, right? Oops, I'm all shaking. Yeah, right here. Ooh, you see it's bubbling? Yeah. What's going on? It bubble up. Sodium bicarbonate bubbling up. Interesting. Why is it all bubbling? You can ask your instructor. I don't know. It just bubble. Alright. I think I want to add a little more sodium bicarbonate. Right? What is sodium bicarbonate doing? Something to think. I'm just going to add a little more. More bubbles. Yeah. So, you see, maybe with the darker black background. Yeah, you can see the bubble. Okay, so let this one sit. Let's see. I think this is good enough. So it has stopped bubbling. That's good. So I'm going to transfer this solution, clear solution, into another clean valve. So here I have a new pressure pipette. Yeah. You don't want any solid, so I'm just gently going to pipette up carefully here. Okay, it's not much, it's fine. So I have about here 0.3 mil, using the conical valve here, about less than 1 mil, which is fine because I only need a drop for GC analysis. I'm going to leave some of the solution behind and solid behind, because if I pipette further, all the solids are going to go into this clean solution. So that's okay. I lose some product here. And I'm going to cap it, seal it. Oops. Right. Yeah. So now I have my product. So I'm going to prepare a GC sample. So this is your GC valve, right? And I'm going to add dichloromethane solution to dissolve the alkyl halide, because GC analysis only takes about microgram of the sample. You don't need a lot, so you only need a drop. Oops, drop it. Here. Okay, so 1 drop of the sample. Need a drop. 1 drop is plenty. And dilute it with dichloromethane. Oops. Yeah, that's okay. I still have plenty. So, and quickly cap the valve, GC valve. So there, I'm going to analyze it later. I still have to wait for that 1 pentanol to finish refluxing. So I'm going to leave it here. Recap this one, seal it tight. Because those alkyl halides, they are very volatile, right? So you want to keep it tight. Alright. So part A, reflux, is done. It's 60 minutes, so I raised the reflux set up, I raise it up to let it cool. It's still hot, so let it cool. So once it's all cooled down, I will add 0.75 ml of pentane. Okay. So 0.75 ml of pentane into reaction flask. So it's already cooled down, so that's okay. We can add it. Why do we add pentane? I don't know, because that manual says so. So why do we add pentane? And let the two layers separate, right? On the top is your alkyl halides again, and at the bottom is what? Aqueous layer, yeah? So now, oh, you can't see that yet, so we're gonna have to let it sit for the layers to separate. So the question is, why do we add pentane? So the layers are separating with pentane and alkyl halide. Layers is on the top and the bottom is the aqueous layer. Okay, so it's difficult to see from here. Will that make it worse? Yeah. So I'm going to pipette out the bottom layers and put it in aqueous waste. It's going to be tough because at the bottom you see some precipitates as well. So you want to make sure you're leaving the top layer behind in a round bottom flask. Yeah, this is, yeah, I still have the top layer, so I'm always checking to make sure I don't pipette out the top layer. So push it all the way down. Oh, this is going to be tough because I have a lot of salt at the bottom. Oh, this is bad. I'm going to get a new pipette. Yeah, my pipette is getting clogged with precipitate. So I'm still pipetting out the bottom layers. You see some precipitate at the bottom too here. Yeah, it's possible. So I've pipetted out most of the aqueous layer. So I'm left with the top layers. Still has some water at the bottom, but that's okay. So I'm going to slowly pipette that top layer out, leaving the solid behind as much as possible, and put it into a clean conical valve. Yeah, so you see a lot of precipitate at the bottom. Oh, I don't like that. Oh, okay. So tilt it and slowly pipette up. I don't want the solid. Oh. So now let the solid settle. I change the pipette again. So I got new pipette here. So that's okay. I think this is good enough for me. So Yeah, so you see the bi-layer still, so there's still water in there, but I do have some product at the top, so which is good, and some of them stayed left behind, so I lost some products here as well, but that's okay. So the bottom layer can be removed. Now we can see better with the conical valve, right? So now you see the two layers. One is cloudy and one is clear on the top, right? So I'm going to use a clean pipette again, and I'm going to take this one out. So I now have one layer, right? The top layers is left behind. That's good. It's okay, good enough. I'm going to cap it back. And the next step is to add 1 ml of water and shake it. So why are we adding 1 ml of water? I don't know. I'm going to leave this for Zoom time discussion. Add 1 ml of water. I'm just doing what the procedure said, right? We just do. We just do right here. We just do. Shake, shake, shake. So why do we add water here? Ask your instructor during Zoom time. And let this layer separate. So I'm going to let this sit. So now we have, it's been sitting for about 5 minutes now. It's hard to see the bi-layers. Yeah. The bottom's supposed to be aqueous layer and the top is organic layer where your alkali halides are. So I'm gonna slowly remove the bottom layer again using clean texture pipette. This is even harder to see here. So this is, now you can see a little better because I removed most of the water. So you see the small layer, the bottom here. Yeah. So, okay, continue. You notice I put it in a beaker instead of aqueous waves because I'm not sure, you know, whether top or bottom. So if you're not sure, you know, you always keep the layers, right? I know it's aqueous at the bottom, but I don't want to mess it up. So I just keep it for now. Just in case if I make mistake, right? So now the next step is what? Add 1 to 2 ml of saturated sodium bicarbonate, right? So 1 to 2 layer, so it's about 1 to 2 ml, sorry, 1 to 2 ml, so saturated sodium bicarbonate. Okay, and again, shake, 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 let it shake, close it, and shake. Okay, vent it, shake and let it sit for a while. So after sitting for a few minutes, you can see the 2 layers now, right? So the top is organic layer and the bottom is aqueous layer. So I'm going to pipette the bottom one out again. So here I need glass pipette, so get another clean one, take the bottom out. Okay. have the top layer, which is good. Get another pipette. I always use clean pipette, right? Because the bottom layer is water. You want to remove as much water as possible. So in this little test tube here, I have anhydrous sodium sulfate. Right, I'm going to dry the solution, the organic layer. Yeah, this is good. So the sodium sulfate is all clumping up, which is good. That means taking away, absorbing all the water, right? So, yeah. So now you can prepare GC sample. I only need a drop, so again, a clean GC valve. Add dichloromethane. I'm just gonna rinse it out a little bit. About 1 ml. And get a clean pipette again and add a few drops of the sample. Okay. One drop is enough actually, not a few drops. 1 drop is enough. Oh, catch the drop. Oh, I missed it. Yeah, 1 drop is enough. Okay. I'm going to keep the samples in a clean valve. I'm going to transfer it into a clean valve. Okay.